Hi guys, and in today's video, which is aimed at GCSE students, I'm going to be teaching you how to remember all the values for sine, cosine and tan x that you need to have memorised for your non-calculator exams. You need to know what cos of 60 is and tan of 30. You need to know all these values for your upcoming GCSE exams, or one of these will be on your non-calculator paper. So I'm going to teach you how to remember them, and all you need to know is sin x. Sin x is the only one that you fluently need to know off by heart, and I'm going to show you why. And it's using these two things. So sin x and cos x are related. They're translated, the graph of sin x translated by 90 degrees in the positive x direction is cos x. As you can see, this is sin x, and this is cos x. I'm just trying to work out if the camera can actually see that. But what if we move like the start point of sin x by 90 degrees? It's exactly the same. Just you'd have the other, 90 degrees on the end, because sine and cosine go on for infinity. They keep repeating forever and ever. And knowing that will be a huge help later down the line when we're doing this. So sine equals cosine translated by 90 degrees. And this other formula, which I'm not completely sure is on everyone's GCSE spec, but it is worth knowing. So tan x equals sin x over cos x. It is a fraction. Sin x over cos x equals tan x. And we are going to use that to deduce all our tan x values. So we're going to start. We're going to start looking at the graph of sin x, and when I was thinking of these values, I was just doing this in my head. So I was just thinking, okay, this is what sin x looks like when I was doing my GCSEs, and that's how I remembered it. So I was like, okay, when x is small, so we start at 0, just like y equals x. When x equals 0, y equals 0. So sin 0 is 0. Sin 30. Sin 30 is one of those that you just have to remember, but you will remember it. It's very common. It comes up all the time. Sin 30 is a half. And now we're into the territory where things get a little bit confusing. So these two, sin 45 and sin 60, these are ones you just have to memorise. There's not really any nice way to remember them. I just do them. I just try recall this table. Just do it just do it once a week up to your exam, and you'll be perfectly fine. You won't forget them. Because it is quite a big deal if you don't know these, because these will cost you marks. These could come up mid-question. You'd have to know on your non-calculator paper what sine of 45 is, and you can't remember, and that won't let you to the next step of the question. Of course, you could get method marks, but it's so much easier to just follow the whole thing through. So you just got to remember that sine of 45 is root 2 over 2. I remembered it by the middle sine value is the same thing over the root of the same thing over the same thing, but it doesn't matter how you remember it. Just remember that sine of 45 is root 2 over 2. And that sine 60, same thing, you just have to remember this, is root 3 over 2. So they're both over 2, you just got to remember the bigger numbers, the bigger root. You got to remember it somehow. And we know that when sin x, we know that its max value at 90 degrees, that's 90. Of course, I'm not sure if the camera's picking that up, but that is 90 degrees. It's the tallest point, and we know that with our trigonometric functions, the maximum value that sine and cos have is 1. Boom. And now, that's all you need to memorise. I'm glad to tell you that. You don't need to memorise any more of these values. So, now, using that bit that we showed earlier, sin x being cos x translated, we can write cos as just the backwards of sine. You can prove it if you'd like in your own time, but you can prove it with your calculator, but take my word for it. This is the easiest way to memorise. Don't go, I've got to remember all the sine ones, I've got to remember all the cos ones, and remember all the tan ones. You can just prove it from these 2 points, and all you have to do is remember these couple values. Because everyone knows that sin 30 is a half, and everyone knows that sin 0 is 0, and Sine 90 is 1. You remember those. These two are the only ones you have to memorise, but once you've memorised them, that's it. So for cos is just sine but backwards. Because we know when cos starts, it's at its maximum already, and it moves like that. Ooh, with that final bit going back up. But right now, today, we're literally only looking at this bit, because that's the only bit between 0 and 90 degrees. Anyways, so cos is just the backwards of sine. So we're going to start here and move back along. So sine cos 0 is 1. Cos 30 is root 3 over 2. Cos 45 is root 2 over 2, because, yeah, they're the same function. The middle values are the same. So translate function. And then sine, we're going to go back along. We've done that one, so we're going to keep going back. And then cos 60 is 1/2. And then we're going to go back even more. Cos 90 is 0. Look at the order of that, and look at the order of that. It's the same, just backwards. And that's it. That's how you can deduce cos for any value. You just know that it is the backwards of the sine one. So if you write out all the sines, you can write out all the coses. It's just the backwards one. And then, yeah, so now is why it's worth knowing this fact, is to save us having to memorise all these tan values, we can just use this. And because we know sine, which we proved lets us know cosine because it's the backwards, we can just do tan from that using the fraction. So if you do want, in the start of your exam, for your non-calculator paper, I would actually recommend just, if you're not confident that you know them off by heart properly, as you get into that exam, write it down on the front. Or just write it down somewhere. They're not going to take marks away from you. As long as it's not in the working out of another question, you'll be fine. Just get it out so you've got all your values there. And you can redraw the table. It takes like 30 seconds to just quickly redraw all this out. But it's worth doing. So, yeah. So for tan, we're going to do this. So we're going to write everything as a fraction of sine over cos. So sine over cos, 0 over 1 equals 0. Anything divided by 1 is itself. You know that. For 30, so the weird thing is with tan is that you get some weird values for tan. Everything that appears in cos appears in sine, as we've shown, but for tan you get some weird ones, which is why I like to remember it using sine over cos, because it expresses it in a much nicer way. So we can just do 1/2 divided by root 3 over 2, and you can bring the 2 down here and that 2 back up there, but it's easiest to just cross out the 2's, which equals 1 divided by root 3, which I'm going to draw that a little bigger. That is 1 divided by root 3. You can do that by cancelling. 1 divided by root 3 is tan 30. And then we're going to do the same thing here. Ah, look. Root 2 over 2 divided by root 2 over 2. What's 2 divided by 2? It's 1. What's 3 divided by 3? It's 1. What's anything except 0 over anything except 0? It's 1. Any number over itself is 1. Look at this. Root 2 over 2 divided by root 2 over 2. It's a over a. Any number over any number. It's 1. Tan 45 is 1. Tan 60. So, right, I've decided I'm going to use this nice little bit for working out so I can make my values quite big in there. Tan 60, root 3 over 2, divided by, big divide, which is that one, half. So 2 goes out, equals root 3. Boom. Ah, and now this one's where it gets a little bit weird. Is that we have, so 0 divided by 1 is easy, but 1 divided by 0 is a little more weird. So we cannot divide by 0. So I'm going to tell you the answer off the bat, and I'm going to explain it a little more. So if all you're interested in is this table, the answer is literally undefined. That's your technical answer that any mark scheme will let you get away with, does not exist, won't won't work. Not real. Like not. Don't say not real because you'd get away with not real, but not real's not technically mathematically accurate. Not possible. Anything that just say you can't do it. That works too. That's an acceptable answer. So your answer is literally undefined. I'd be very surprised if they asked you what tan of 90 was, but they technically can. You're expected to know it. Just can't happen. And this is because of one of those things. So we're going to take 1 over 0 as our example. And we're going to look at the graph. Yeah, I was going to say, you know everything you need to, but if you're interested, we're going to look at the graph. Oh, that's not so good. We're going to look at the graph 1 over x. As x gets closer and closer to 0, the graph goes up and up and up and up towards infinity. However, it never ever touches the y-axis. So when x equals 0, it does not in fact lead to infinity. Do not fall into that trap. Anything divided by 0 does not exist. The only way it could be infinity is if you were using a limit, so you did tan x, limit x to 90, but that is A-level, and even then a lot of A-level people don't properly understand what a limit is. So don't worry about that at all. Just know that that is undefined. Dividing by 0 is not ever possible. Because if you could divide by 0, you could pretty much just divide by your equation by anything. Let's say I wanted like x equals x squared plus 7x, or I don't know, if you want to divide by 0, you could just divide everything by 0 and it just doesn't work because you can't divide by 0. It's not mathematically possible. So yeah, there's your table. I hope that leads to be useful, and I hope that you guys all know that for your upcoming exams, and I wish you guys the best of luck. Thank you for watching. Have a lovely day.